Okay, may not be the most beautiful thing in the world, but hopefully it's going to work. So my counting method of the unit circle is, we got our unit circle here, real fancy. We're going to make multiple laps around it. You're not going to do this all in one sitting. And you need to know that this piece right here, this is always the starting point, ground zero, home base. The positive x-axis is always where we start. So the first lap that you make, lap number 1, we're going to go around and we're going to count by halves. We're going to go 1 half, 2 halves, 3 halves, 4 halves. And those are going to be the XY axis. They're called the quadrantals. So lap 1, count by halves. That's the quadrantals. And I'm doing this in radians. We can also do it in degrees, but usually we do it in radians. So we start here, that's 0. And then we come up here and we go 1 half. Well, 1 half times pi is pi halves. So I'm going to go 1 half, 2 halves. Well, 2 over 2 times pi, 2 halves, is 1. So this side right here becomes 1 half, 2 halves, 3 halves, and back here at the beginning is 4 halves. 4 over 2 is 2 pi. So the first lap, count by halves. 1 half, 2 halves, 3 halves, 4 halves. Now we're going to make another lap. And the thing to recall is that every time we make a lap and we count, every time we hit a quadrantal, we include it in our count. It keeps us on track. So lap 2, we're going to count by fourths. We're going to hit what I call the quarter marks. So that's going to be, if we take each quadrant and then cut it in half again, these are what I think of as the quarters. Start at 0, positive x-axis, and we're going to go 1 fourth, 2 fourths, 2 over 4 is 1 half, got it labeled, 1 fourth, 2 fourths, 3 fourths, 4 fourths, 4 over 4 is 1, we're good, 5 fourths, 6 fourths, 6 over 4 reduces down to 3 halves. 1, 2, 3, 4, 5, 6, 7 pi over 4. And then back here, we're at 8 pi over 4. 8 over 4 is 2. So we're on track because we always want to start at 0 and we should end at 2 pi. And then our next lap is, we're going to count by sixths. And this is going to finish out our circle. And this is where we do the other 2 splits, the 30 degrees and the 60 degrees in each quadrant. So every quadrant is going to be divided into 3 sections. 30 degrees, 45, 60, and then 90. And all we're doing by this counting is converting 30, 45, 60, 90 into radians. So when I go back around on this next lap, I'm going to count by sixths. And all I have to remember is that every time I pass a quadrantal, I count that. So this first one right here, 30 degrees, is 1/6. So that's pi over 6. 1/6, 2/6, 2 over 6 is pi thirds. So we have 1/6, 2/6, 3/6. Can't say sixths very well. 1/6, 2/6, 3/6, 4 over 6. 4 over 6 becomes 2 over 3. 1, 2, 3, 4, 5 pi over 6. 6 pi over 6. 6 over 6 is 1. I'm on track. 7 pi over 6. This is 8 pi over 6, which reduces down to 4 over 3. 4 pi over 3. And sometimes if I get off count, I'll stop. I'll go back to the beginning. 1, 2, 3, 4, 5, 6, 7, 8, 9 over 6. Cool. That means this is 10/6, which is 5/3. 11 pi over 6. And we're back to 12 pi over 6. 12 over 6 is 2. Cool. Now what we're going to do is we're going to label them, because what the unit circle is doing is it's giving us some real unchangeable landmarks that we know the 6 trigonometric functions for. And it's kind of just an easy way to learn these things. So if we see a trig problem and we see cosine of 5 pi over 6, we remember that 5 pi over 6 is one of our major landmarks on the unit circle. 5 pi over 6 is a landmark on the unit circle. 5 pi over 7 isn't. So that's a different animal. But if I get thrown a sine, cosine, tangent, secant, cosecant, cotangent of any one of these angles on the unit circle, I know its value because of the unit circle. So if I go back through here, just imagine this is an XY axis, good old fashioned 7th grade X and Y axis where you graph points and lines. We just threw a circle on there. And we have our origin. And so I'm imagining, okay, if I started at the origin and I navigated to this point, what would the coordinates of that point be? Or if I started at the origin and I navigated to this point, what would the coordinates of that point be? So we're going to have X coordinate, Y coordinate, but when we're on the unit circle, the X coordinate is the same as the cosine, and the Y coordinate is the same as the sine. It's just how they translate. So here's something that's really cool about the unit circle is for your coordinates, you only have 5 options for numbers, and they're pretty easy. Every coordinate on here is either a 0, a 1, a 1/2, a √2 over 2, or a √3 over 2, and the positive or negative version of those. And the nice thing about the unit circle is that the 0s and 1s always come together. You're never going to see a 0 with a √2 over 2 or a 1 with a 1/2. It's always a 0 and a 1 together. And the √2 over 2 always shows up as a twin. You're never going to see a √2 over 2 with anything other than a positive or negative √2 over 2. And so that means that the 1/2 and the √3 over 2, they always come together. So let's do this. We'll go back in our same order. We'll start with the quadrantals. Those are easy. If we start here at the center and we run out to here, that means the coordinates of this point are 1, 0. That's it. And up here, the coordinates are 0, 1. And if we start here and go that way, our coordinates are -1, 0. And if we start here and go straight down, that's 0, -1. So what this means is if they say, what is the sine of 3 pi over 2? You go to the location of 3 pi over 2 on the unit circle and you grab the y coordinate and you're done. That's it. The sine of 3 pi over 2 is negative 1/2. Done. The cosine of 3 pi over 2 is 0. So go back around and do your quadrantals first. Those are zeros and ones. Then go back and do your quarter marks. Those are always your twins. Root 2 over 2, root 2 over 2. So here at pi fourths, that's one of my quarter marks. Since we're in quadrant 1, that is root 2 over 2, root 2 over 2. Over here, if I start at the origin and I go left and then up, I'm going negative root 2 over 2, positive root 2 over 2. And if I'm down here in quadrant 3, I'm negative, negative. So this guy is negative twins, negative root 2 over 2, negative root 2 over 2. And this guy, my last quarter mark, is positive negative. Positive root 2 over 2, negative root 2 over 2. Cool. So now all I have to do is my sixths marks. And the way I remember this is think about, because I never can remember if the 1/2 or the root 3 over 2 comes first. Because I know that this guy's coordinate is either going to be 1/2 root 3 over 2 or root 3 over 2 1/2. And for the longest time, I was like, oh, which one comes first? Well, think about this. 1/2, if you put it in a calculator, 1 divided by 2 is 0.5. And root 3 over 2, if you do that in your calculator, it is about 0.866. It's a little bit bigger. It's just a tiny bit bigger number. So if you think about two little mices, and they start at the origin, and one mouse is gonna run to this point, and the other mouse is gonna run to this point. This mouse is gonna run a lot and jump a little. This mouse is gonna run a little and jump a lot. Mouse down here has to run farther than he has to jump. So he gets the bigger x coordinate. Root 3 over 2, run a lot, jump a little. This mouse, run a little, 1/2, jump a lot. Root 3 over 2. And then that pattern repeats all the way around the circle, just depending on what quadrant. So this mouse compared to this mouse, this guy, run a little bit negative, jump a lot. This one, run a lot negative, jump a little. So over here, we've got negative root 3 over 2 up positive 1/2. And this guy is negative 1/2 up root 3 over 2. So what that means is once you get your circle all filled out and someone says, okay, what's the cosine of 7 pi over 6? You slap down your unit circle, you find 7 pi over 6, you remember what its coordinates are. Okay, that runs a lot. Negative root 3 over 2, drops, jumps a little, negative 1/2, and the cosine is always the x coordinate. So the cosine of 7 pi over 6 is negative root 3 over 2. And if it asked for the secant of 7 pi over 6, okay, you don't scare me. Same location, but the secant is the inverse of the cosine. So you go to the location, you find the cosine, the x coordinate, and you flip it upside down. The end. So the secant is negative 2 over root 3. And lastly, if you are asked the tangent of anything, the tangent is the sine over the cosine. So if they said, what's the tangent of 11 pi over 6? Okay, I'm going to go to 11 pi over 6. I already labeled my circle. I did 1/2, 2/2, 3/2, 4/2. I did 1/4, 2/4, 3/4, 4/4. I did 1 6 2 6 3 6 4 6. I find 11 pi over 6. I know that that is run a lot, jump a little, √3 over 2, -1/2. X is cosine, y is sine. Tangent is sine over cosine. So the tangent of 11 pi over 6 is -1/2 over √3 over 2, which is -1 over √3. Please text me if you have questions. I've got some time this afternoon. I can answer anything. Okay, bye.